So at this school, we decided we would no longer teach antilogs, the topic that's covered in the book in lesson 67. All that an antilog is, so the antilog of, and pick any old number that you want, 2.437, with a base of, pick anything that you want. All that is 2.32 the 2.437. So why bother to do antilog? Why bother with this much extra writing? We'll just say it's something to a power and enter it on the calculator and see what we come up with. So what we're going to do today is we're going to talk about if we have the equation and we want to graph the sinusoid and it has had a period change or a horizontal shift. The steps I'm going to give you are actually what you will use when we do both of those on one graph, but the only problems I'm actually going to give you for the time being will just have one or the other. I am picky on how I grade these, so I'm going through this so that you guys know exactly what I'm expecting so that you can be successful with the homework, with the tests, and get all of the points on these with everything on there that I'm looking for. So please take nice notes with this and write down your examples. When you are turning it into me on homework or a test, I want a straight edge for 3 dotted lines as your starting point. In these notes that you're doing right now, I'm not going to be grading those, so whatever you want in these notes. We will always start with 3 dotted lines, one for the max, one for the min, and one for the center line. The only things that will be solid in the final graph will be the sinusoid curve and the x and y axis, or the theta and y axis. But if these do not end up being an axis, they need to be dotted. So that's why we start with dotted lines. One might change to solid later. Along the center line, we are going to do 5 evenly spaced tick marks for where 5 critical points are going to go. If we are starting out with something that is a plus sine curve, where does plus sine normally start on the y-axis with what you've been doing up to now? Center line increasing or decreasing? Increasing. So since sine normally starts center line increasing, we're going to start center line with a dot. And then for the next critical point, we're going to go straight up above that tick mark and do another dot. So it's going to be center line increasing, then a dot on the center line, then a dot even with the next tick mark but on the min, and then back to the center line. Then we can draw in the curve, and that would be how we would start anything that is a plus sine curve. What if it were a plus cosine curve? How would we start? We'd start at the max. So above the first tick mark for a plus cosine curve, we do a dot at the max, and then we do the other 4 dots as well, and then we would draw that curve through all 5 dots. Notice we would make sure that this one does not start off going outside those 3 dotted lines, because a sinusoid never goes outside the max and the min, and we could draw that curve in. So that's our basic starting point for any graph that we're going to do. Now let's get a specific example up there as I start filling in the other steps. And on these first 2, I'm going to actually have the steps written out for you. The last 2 that we'll do it without the steps written up here. So we start off with the 3 dashed lines. We don't put any axis in yet. We put 5 tick marks in, and this one is plus sine, which is what we just talked about on the last slide. It starts at center line increasing, so we want to make sure that we get these on the tick marks or nice and evenly above or below them. We're going to draw in the curve, and that's our starting point. Center line increasing. I think that's what I've got, isn't it? Okay, next thing we're going to do is we are going to figure out if we've changed the period or not for this problem, so that we can figure out what values we need to start off with for those 5 tick marks. So have we changed the period on this one? So we've got that number in the equation that changes the period. So we will say that the period on the graph needs to be the normal divided by the number in the equation. Is there anything in that equation that says it needs to be degrees or radians? Which means you get to choose. So I'm going to choose degrees on this. I know that's generally what you guys are more comfortable with. So what's normal period in degrees? And what is the number in this equation that I need to worry about? So that means my period on the graph needs to be 180 degrees. If there's no phase shift, is there a horizontal shift on this one? Nope, so we're going to go ahead with these steps. If there is no phase shift, we get to go ahead and start putting these angles directly on our graph. So we are going to label the first one 0, and the last one with whatever we figured out the period on the graph needs to be, which is 180 degrees. So if this had been 1 in the book, and this was labeled 0, and this was labeled 180, would you know, looking at that graph, that the period's 180 degrees? Okay, now we're going to get the one in the middle. This one in the middle needs to be exactly halfway between 0 and 180, or, everybody, 90 degrees. Okay, the second tick mark underneath this max needs to be halfway between 0 and 90 degrees, so it is 45 degrees. Now this tells me that no matter where on the graph we are, any 2 consecutive tick marks are 45 degrees apart. Whether they're between 0 and 45, 45 and 90, or way over here on some sort of negative degrees, any 2 consecutive max-min center lines will be 45 degrees apart. That helps me out here because 90 to the next one has to be 45 degrees. So what's 90 plus 45? So I have all 5 of those labeled. So far, so good. Okay, now I want you to always have critical points on both sides of the y-axis. That means at least one that's negative and at least one that's positive. Do I have positive? Do I have negative? So now I need to extend my graph 1 tick mark to the left. I want the spacing to still be the same. So when you draw your first tick mark, get yourself in the habit of always leaving yourself a little bit of room to the left in case you need to go that way. So I'm going to say my space is about this far, so about that same distance to the left would be right about here. Next critical point, if this one was a center line, next one would be a min. So I'm going to draw that in and extend my curve, and again, make sure it curves back inside that min and max, that it never goes down below the min. Now I need to figure out how many degrees to put on that new tick mark. They are not always symmetrical. Just because your first one to the right might be 10 degrees does not mean your first one to the left is negative 10 degrees. You have to do it with the subtracting and looking at it. In this case, these are 45 apart. So what is 45 to the left? So this one happens to be symmetrical, but that's not always going to be the case. Okay. Now we still need to add the axes, and we need to label max and min. Make sure our graph is finished up. So what is my center line for this graph? 0, which means that center line is actually the horizontal axis. So I can now change it so that it is solid. Make sure that I've got the arrow on the end of it, and make sure it's labeled with the same letter as the equation. The y-axis needs to go on the angle that's 0. Well, this one's nice. We actually have 0 labeled on here. We did not have a horizontal shift. So now we go in and we label that with y. What is my amplitude for this? My amplitude is 1. So since my center line's on the axis, I don't have to write a 0 on that. but I do need to label that my max is 1 and my min is -1. And I need to make sure that I have arrows on both ends of the sinusoid because it does not stop, it keeps going forever. So does that one make sense? Okay, we're going to do one with a phase shift with degrees, and then we're going to do one of each kind with radians, just so that we have all of those examples in here. So y equals sine x plus 30 degrees. Start by drawing with a straight edge 3 horizontal parallel dotted lines. Make sure they're pretty much evenly spaced. Get the tick marks, 5 tick marks on that middle one with enough space to the left in case we need to make an adjustment to the left. Next, we worry about the period. Have we changed the period on this one? No. No, there's no number right here before the x. So we have not changed the period, so it's the normal period. Am I going to use degrees or radians on this one? Because of the 30 degrees, it must be degrees. So we know that the period must be 360 degrees. So I'm going to write that down here. Do we have a phase shift on this one? That means do not go ahead and write your angles on the graph. We're going to do it as scratch work. I used to have students actually draw it on there, cross it out, change it, and then redraw the whole thing. But let's be a little bit more efficient with our time. If there is a phase shift, I want you to draw just a quick scratch work number line only. So not in the middle of this, but maybe down here somewhere. Here's my number line, and I'm going to do 1, 2, 3, 4, 5 tick marks. My period is 360, so I'm going to label the first one 0 and the second one 360. The last one 360. So what's the middle one, everybody? 180. Half of 180 is, and that means they're all 90 apart, so this one has to be 270. Okay, so we've gone through and we've done all of those steps like we did before. Now, since there is a phase angle, we need to change each of those numbers on this scratch work number line to figure out what we put on our real one on our real graph. So the way that we're going to do this is in our formula x minus phi, right? The way we did our general formula. So what is phi? What is the phase angle for this one? It is negative 30 degrees. That means I need to minus 30 each of these 5 numbers I wrote down on my scratch work. So this needs to be 0 minus 30 is negative 30. What's 90 minus 30? It's going to give us 60. What's 180 minus 30? So I'm going to go ahead and those are going to be my values for my real number line. Oh, I never did draw my sketch. Okay, we'll get that in there too. So that would have been negative 30, 60, 150. Should have gone ahead and drawn my sketch. So center line increasing since it's a plus sign again. So there's my curve so far. Now, I can keep doing 270 minus 30, 360 minus 30, and that's totally fine and okay. The other thing you could do is to say, well, these two critical points, negative 30 and 60, are 90 apart. 60 and 150 are 90 apart. All critical points, therefore, are 90 degrees apart. So we could do 150 plus 90 is 240, if we liked that better than 270 minus 30. We could do 240 plus 90 is 330, if we like doing that better than 360 minus 30. So everybody good to there? Okay, then we need to make sure we have at least one negative and one positive critical value, do we? Yeah, we've got negative 30, we've got positive 60, so we're good with that. We don't have to extend this one. So we're going to add the x-axis and the y-axis. So what is the center line? So that means that the center line is the x-axis. So let's put that in here. And this needs to go where the angle is 0. So is it center line increasing? No, that's where the angle is -30. So the y-axis does not belong there. Where should I put it instead? Well, where does that go? Very good. It's got to go between the negative and the positive, not right smack in the middle. It needs to be closer to the -30, so about a third of the way along. And then we need to make sure everything's labeled. So this problem used x and y, so we labeled horizontal x, vertical y. You told me center line was 0, so I don't need to label that. What's the amplitude? So I need to label that my max is 1 and my min is -1. And I need arrows on both ends of the curve. And I think that's got everything up there. Does that look good to you guys? Questions on degree ones? Okay, let's shift to radians. So tell me about this one just by looking at it. What are some things you can tell me? Grace? We've changed the period. What about horizontal shift, okay? Okay, so we've changed the amplitude. What is the amplitude? Okay, what about vertical shifts? What about center line? It's still going to be 0, 0. Now the next one we're going to change all of that as well, just so we get some practice with all of that. So we're going to have a period change. We're not going to have a horizontal shift. We are going to have a different amplitude. This one is a minus cosine graph. So how do I start a minus cosine graph? At the min, so underneath my first evenly spaced tick mark, I do a dot on the min, and then I do a dot on the center line. I do a dot above the next one, on the center line, down to the min. Fill this in, make sure I turn so it does not look like I'm thinking about going outside those 3 lines. And since you guys went ahead and told me the center line was 0 and we had an amplitude change, what is the amplitude? 2, so that means I'm going to have 2 and -2. And since we already talked about the center line, we might as well go ahead and we can change this to a solid line now if we want to. Okay, next thing we have to do is to figure out what the period needs to look like on the graph. So the period on the graph needs to be normal over the p in the equation. Is there anything in this equation that says degrees or radians? Not in the equation. The only thing saying that we're going to do it with radians is your teacher says we're going to do it in radians. So if I write it in on a problem set question, you need to follow those directions. So what is your normal period for radians? 2 pi, and what is the p in the equation? 2/3. So if I'm dividing by a fraction, I take the fraction, turn it upside down, multiply. So my period on the graph needs to be 3 pi. Since there is no phase shift, I can go ahead and write my angles on my first graph. I do not have to do scratch work. So my first one is going to be 0, and my last one is going to be 3 pi. Read, what's the middle one? Yeah, keep going. It has to be halfway between 0 and 3 pi is, what's half of 3 pi? So 3 pi over 2. Now the next one has to be halfway in between 0 and 3 pi over 2. So what's half of 3 pi over 2? 3 pi over 4. That means all of my critical values are 3 pi over 4 apart. So that means to get my missing one here, I need 3 pi over 2 plus 3 pi over 4. So if I have a common denominator, does 9 pi over 4 sound about right? Do I have at least one positive and at least one negative? Nope, so I need to extend it. So I'm going to first make sure that it's equally spaced and do a tick mark. These are all 3 pi over 4 apart, so I look at the last one that I have, 0, subtract 3 pi over 4. This one's nice and symmetrical, so minus 3 pi over 4, and extend my curve to go through that. Okay, we've got the horizontal axis in. Vertical axis has to go through 0, so let's put that one in. And let's make sure we have everything labeled. This time in my equation I have theta and y, so that's how I label the axes. And let's see, we've already labeled max min center line. We've labeled our angles, just add an arrow on that end and we're done. Making sense so far? Much easier to draw the graph and then label the angles. Do not try to label the angles and then make the graph fit to that. So let's try one that has more things going on in it. Does this one have a period change? No, no period change because there's still just a 1 in front of that variable. So the period is going to be how much for this problem? It's going to be the normal period. It's still got to be 2 pi. And how did we know it was radians? Because we see the minus pi over 4 in the equation. Right. Do we have a phase shift for this one?
Yes.
What is phi for this one? It is positive pi over 4. And I didn't really stress it on this one, but with a plus, that meant a shift to the left. So when we subtracted 30, did we get a shift to the left for that graph? And we'll double check the same kind of thing with this one in a moment. What is the center line for this one? And the amplitude? So that means this is going to be 1. What will the max be? And what will the min be? Okay, this one is a plus cosine graph. Where does a plus cosine graph need to start? At the max, so we've got our 5 evenly spaced tick marks. Above the first one, we do a dot on the max line, and then we fill in our others, and we draw in our curve, being careful to turn so that it's clear that we do not go outside those 3 lines. Since this one has a horizontal shift, we have to do scratch work. So we're going to draw a scratch work number line, 1, 2, 3, 4, 5 marks on there. Since the period is 2 pi, the first one's 0, the last one's 2 pi. What's the middle one? What's the second one? And then that means 3 pi over 2 in terms of our scratch work there. Okay, phi is plus pi over 4, so we need to plus pi over 4 for how we're going to label our real ones. So our first one is 0 plus pi over 4. Our second one is pi over 2 plus pi over 4. So let's see, 2 pi over 4 plus pi over 4. What's the second one going to be? So 3 pi over 4. And let's see, what's pi plus pi over 4 going to be? 5 pi over 4. Now we can keep doing the plus pi over 4s if you like that way best. Or we can look at the numbers we've written down so far. Pi over 4 plus 2 pi over 4 is 3 pi over 4. 3 pi over 4 plus 2 pi over 4 is 5 pi over 4. So if I add 2 pi over 4 each time, I'll get the others. So plus 2 pi over 4 is 7 pi over 4. Plus 2 pi over 4 is 9 pi over 4. Do I have at least one positive and one negative? So I have to go back to the left, so keep my same spacing. And now I need what is the last one that I had, pi over 4 minus 2 pi over 4. What's that going to give me? Negative pi over 4 is how I'm going to label that one. Need to extend my curve so that it goes through that. And I'll go ahead and get my arrows on both ends. Need to put my axes in. So horizontal axis, is that good right there on the center line? What's wrong with that? That's 1. It needs to go on 0. So it's got to go between the negative and the positive, closer to 1 than to 2. So about there. What about my vertical one? Does it still go through that starting max since it's a plus cosine function? Where does it need to go? It's got to go between the negative and positive. And this time, since they're symmetrical, right at halfway in between, my variables are theta and y. And double check. Do I have both axes labeled? Max, min, center line. Angles labeled. Curve drawn with arrows on both ends. So I think we have finished that one, unless anybody has questions.